welcome to G Fun Facts Online. Today, we're talking about the invisible backbone of our world, the supply chain. Everything you own, from your phone to the coffee in your mug, made a long journey to reach you through this incredibly complex network. For decades, this intricate dance was managed by traditional computers. But the sheer amount of data now flooding these networks, from tracking sensors, real-time traffic, and even social media trends, has pushed these old systems to their breaking point. The result is a system that's inefficient, opaque, and dangerously fragile. But a revolution is underway, powered by a piece of hardware you probably associate with video games, the Graphics Processing Unit, or GPU. This is the story of how a component once coveted by gamers became the most critical tool for solving the biggest challenges in global logistics. The modern supply chain is a data-generating behemoth. Every pallet, container, and truck is a source of information. IoT sensors report a package's temperature, RFID tags are scanned at checkpoints, and GPS trackers transmit real-time locations. When you layer this with external data, weather, port congestion, fuel costs, and unpredictable world events, you get a data tsunami that traditional systems just can't handle. For decades, the industry relied on central processing units, or CPUs. CPUs are masters of sequential processing, designed with a few powerful cores that execute tasks one after another very quickly. This is perfect for running your web browser or word processor. But when you face the supply chains need to analyze millions of variables at once, the CPU's one-at-a-time nature becomes a critical bottleneck. Imagine trying to calculate the best route for a single delivery truck. A CPU has to consider distances, time windows, traffic, and driver hours. Now, scale that to a fleet of thousands of vehicles. The number of possible route combinations explodes into the trillions. This is a classic puzzle known as the vehicle routing problem. A CPU, tackling these possibilities one by one, could take hours or even days to find a good solution. By the time the calculation is done, real-world conditions have already changed, making the plan obsolete. This is the computational wall. So if traditional computers hit a wall, what's the sledgehammer that breaks it down? The answer is the Graphics Processing Unit. While a CPU has a handful of powerful cores for sequential tasks, a GPU contains thousands of smaller, more efficient cores designed to work in parallel. This architecture was born from the need to render 3D graphics, where the color and position of millions of pixels on a screen must be calculated at the same time. This concept of massive parallelism is exactly what supply chain problems need. Instead of analyzing one potential delivery route at a time, a GPU can evaluate thousands or even millions of them simultaneously. This leads to performance accelerations of 100 times or more on many tasks. This power is unlocked by software platforms like NVIDIA's CUDA, which allows developers to use GPUs for general computing and specialized toolkits like NVIDIA Rapids for data science, CUOPT for route optimization, and Omniverse for creating realistic 3D simulations. Let's look at how this is changing the game, starting with the holy grail of supply chain management: accurate demand forecasting. Underestimate demand, and you get stockouts and lost sales. Overestimate, and you're stuck with excess inventory and high costs. Traditional forecasting, using old sales data, struggles in today's volatile market. GPU accelerated computing changes this by enabling sophisticated deep learning models that can analyze a much richer set of inputs, including market trends, weather, and even social media sentiment. The world's largest retailer, Walmart, provides a stunning example. They face the task of predicting demand for over 100,000 products across thousands of stores, resulting in 500 million forecasts every week. By turning to a GPU-based solution, Walmart's data science team accelerated their machine learning pipeline by 20 times. This speed allowed them to use more complex algorithms that were previously impossible to run. The result? A forecast accuracy improvement of up to 4%. That might sound small, but for a company with over $330 billion in sales, it translates into billions of dollars in value through fewer stockouts and optimized inventory. This accuracy allows businesses to proactively position inventory where it's needed, even before the customer thinks of buying. Now let's step inside the nerve center of the logistics network, the warehouse. The next wave of automation isn't just about robots following lines on the floor. It's about making the warehouse truly intelligent. This transformation is driven by edge computing devices, small, powerful computers with GPUs, like the NVIDIA Jetson platform, located directly on robots and cameras. These edge GPUs run complex AI models in real time. Computer vision systems powered by these GPUs can instantly identify damaged packages on a conveyor belt, verify that the correct items are in each box, and even monitor worker safety by detecting if someone is in a hazardous area. The most visible change is the rise of autonomous mobile robots, or AMRs. These robots navigate freely and intelligently. To do this, every AMR must solve the problem of simultaneous localization and mapping, or SLAM. It has to build a map of its constantly changing environment while figuring out its own location within that map. This is computationally demanding, and GPU acceleration is essential for the robot to process sensor data and make navigation decisions in milliseconds, avoiding obstacles and finding the most efficient path. Through these GPU-powered advancements, warehouses are transforming from static storage facilities into dynamic, highly efficient, and safer ecosystems. From the warehouse, let's follow the product on its journey. The final leg of delivery, the last mile, is notoriously complex and expensive, often accounting for over half of total shipping costs. The challenge, again, is the vehicle routing problem. A CPU-based solver can take hours to produce a static plan that is quickly outdated by real-world events. This is where a tool like NVIDIA CUOPT comes in. It's a GPU-accelerated engine built to solve these problems at unprecedented speed. By using its massive parallelism to evaluate tens of thousands of potential route improvements every second, CUOPT has broken world records, delivering high-quality solutions up to 100 times faster than CPU-based solvers. What takes a CPU hours now takes a GPU mere seconds. This unlocks a dream for logisticians: real-time dynamic rerouting. If a freeway clogs up or a high-priority order comes in, a new, optimized plan for the entire fleet can be generated in seconds. For instance, one organization used this technology to optimize routes for its field service technicians, getting results 100 times faster, reducing costs, and enabling more jobs per technician per day. In massive factories, GPU-optimized routing for internal robots can reduce operational costs by up to 20%. This saves money on fuel and labor, increases deliveries, and improves customer satisfaction. But what if you could go beyond just reacting to the present? What if you could test the future? This is the promise of the digital twin, and again, GPUs are the engines making it a reality. A supply chain digital twin is a living, virtual replica of a physical warehouse, factory, or even an entire network, continuously updated with real-time data. This virtual environment, built on platforms like NVIDIA Omniverse, becomes a risk-free sandbox for simulation and what-if planning. GPUs are essential for both rendering a visually realistic twin and for simulating the laws of physics within it. A global manufacturer created a digital twin to optimize its logistics and cut freight and damage costs by 8%. Other companies report up to a 30% improvement in forecast accuracy and a 20% increase in production output. Electronics giant Foxconn is using Omniverse to create digital twins of its factories, allowing them to simulate and optimize automated production lines in a virtual setting before building anything. This allows companies to test strategies, de-risk innovation, and build supply chains that are not just efficient, but profoundly resilient. Now, there is a great irony at the heart of this revolution. The very hardware that promises to solve supply chain problems is itself the subject of one of the biggest supply chain crunches in recent memory. The explosion of interest in generative AI has created an insatiable global demand for high-end GPUs. Manufacturers are operating at over 90% capacity and still can't keep up. The process of making a single GPU is a marvel of global logistics, with a chip traveling over 25,000 miles and crossing more than 70 borders. This bottleneck has forced companies to get creative, placing huge pre-orders or renting GPU power from the cloud instead of buying the scarce hardware. This paradox highlights just how critical and complex these global networks are. So what's next? The revolution is just getting started. The power of large language models, the tech behind ChatGPT, is being harnessed to create a new conversational interface for the supply chain. Instead of clicking through complex dashboards, a planner could simply ask, "What's the root cause of the delays at the Port of Singapore, and what are my top 3 mitigation strategies?" Or simulate the impact of a 10% increase in fuel costs on my budget. Generative AI can analyze vast amounts of data to provide these answers in plain English. At the same time, intelligence will be pushed further to the extreme edge. A delivery driver's handheld device could dynamically reroute them in real time. A smart pallet could sense its own environment and communicate its needs. And critically, this same optimization power also drives sustainability. Every gallon of fuel saved is a reduction in carbon emissions. Every product that avoids spoilage is a reduction in waste. As sustainability goals become more important, the GPU's role in creating greener logistics will be a key driver of its adoption. In conclusion, the supply chains of the 21st century are no longer just about moving physical goods. They are about moving data. The ability to process and act on that data in real time is the single most important competitive advantage. Accelerated computing, powered by the massive parallelism of GPUs, has shattered the old computational bottlenecks. From AI-driven forecasting and robotic warehouses to real-time routing and digital twins, GPUs are the common thread enabling this transformation. The companies that embrace this shift will build supply chains that are not only faster and cheaper, but also more resilient and intelligent, navigating the complexities of the global market with an agility that was once science fiction. The revolution is here, and it's being accelerated, one parallel computation at a time. Thanks for listening to G Fun Facts Online.